Hi guys, welcome to the last session of graph theory. So in the last 4 sessions, you have seen a lot of spawn leak tricks on how to transform graphs. Particularly in the last class, we have seen how the reflection of a graph looks like. We're going to continue that and actually look at some types of graphs which are reflections and not necessarily symmetrical, but the entire graph is a reflection. So let's take a look at it. There's a slight difference between reflection and symmetry. Okay, so well, that's about me, just skipping this part. So what is a reflection? Reflection is nothing but a mirror image. We already know this. We have seen this in the last class. So if I put a point over here, if I say, give me the reflection of this with your x-axis, then I'll be looking at a point over here. This is my reflection. If I say, give me the reflection of this point with respect to y-axis, then you'll supposed to go left. So it is going to be here, this point. So reflection is nothing but a mirror image. Now a symmetrical graph is one such graph we saw in the last class, which has a mirror built into the graph, which is an imaginary mirror, of course. Now, in this particular session, we are talking about how to reflect an entire graph. It may not be symmetrical at all. So how do I get the reflection of an entire graph? How will the function look like if it is a reflection? So that's what we're going to ponder upon in this particular session. So let's take a look at partial reflection, which is basically starting by understanding mod of f of x. Now, in the last class, we ended up discussing f of mod x. We saw what it is, right? In this class, we're going to look at how will the graph of this entire modulus looks. If f of x is known, then how will this look like? Okay. Now, before we look at the graphs, let's look at what the structure of what we have. Now, because there is a modulus, it means this answer is always positive. Always positive. It cannot be negative at all, which basically means if I draw my x-axis, okay, it's supposed to be horizontal. If I draw my x-axis, then my answer should only be on the upper side of my x-axis. There cannot be anything on the lower side of x-axis because this is y negative, whereas this is y positive. So first of all, mod f of x, you can, by the definition of modulus itself, you can understand that the output, that is the y answer, can never be negative. It will always have to be positive, which means if at all the graph exists, it will exist only on the upper half of your x-axis, not on the lower half. Okay, so how do we draw this graph? Basically, the step to do is keep the upper. So when you have the entire graph, so let's say if I have this entire graph, this is my f of x. I have an f of x like this. This is my f of x. So if I want to find mod f of x, basically what I have to do is, look, modulus will not come into effect as long as things are positive. So if I draw the mod f of x part, this entire region till here, there's no problem because y is positive, which means I don't have to use a modulus. Similarly, this part also, there is no problem, correct? Because it is above x-axis, it is positive, the answer f of x is positive, so there's no need to worry about. And this part till here is no problem. The problem comes in my region here, which is going below, and my region here. Now let us look at this. Let us say this point is -1, which means for some x, let's call this as x1. For this x1, f of x1 is actually -1. So if I want to find f of mod x1, how much will this become? This will become mod of -1, which is +1. So the same point, I have to now take it on the upper side. Same magnitude. Magnitude will not change. It will just go up. Similarly, if I have a point here, I have to take it up because the sign will change. Negative will become positive. Magnitude remains the same. So in effect, what you're talking about is drawing a reflection of only the negative part. So please remember, you are reflecting only the lower half into the upper half. So from bottom, you are just taking reflection onto the top along your x-axis. Already the graph which is on the top, you're not touching. right? So basically what happens is, if you look at it, if I draw it in the graphical manner, if I take a simple graph like this, okay, this is my f of x. It's a modulus. It's some graph. Let's say it's f of x. Now I want to look at how will my mod f of x look like. This, if you want to draw, do not worry about this part and this part. Draw it as it is. So I will draw a graph as it is like this, and I will draw a graph as it is like this. This part will not change. The only thing that will change is the negative side will now start getting reflected onto the positive side. The negative will start getting reflected into the positive side. So this, whatever is in the middle, in the lower half, will now start getting reflected, and I'll get like this. So this is my graph for mod of f of x. So the thing to keep in mind is, do not touch anything above your x-axis. Keep it as it is. Anything below your x-axis, just reflect it with your x-axis. That becomes your final answer. Very, very neat indeed, right? Let's look at a few examples. Let us say I have this graph, y equal to, you have this graph over here, y equal to x by 1 plus x cubed. Don't worry, I'm giving you the graph. Don't worry about plotting such a graph. Now I want to find how will the modulus of this y look like. So this is the original graph. Okay, if this is how the graph is. Now, by the way, guys, if you're concerned about should I know this kind of a graph, you don't need to. I'm using these examples to show that it reflects. Usually, if at all a question comes to you, they're going to use simple questions like x square, or a simple question like sine x. So they use simple functions which you know. You don't need to know complex functions. Okay, you don't need to know the graph of x by 1 plus x cubed. But if this is given, you should know how to get this answer. Now, how do we do that? We know that above x-axis, so this part will not be touched. This part will remain as it is. Okay, only thing is, now I will be getting a reflection. It should be a reflection like this. It will not touch. It's an asymptote. If you remember, this line is an asymptote. Okay, so you can see this curve, this curve will never touch your -1. It will never touch your -1. Similarly, this will also never, this graph, this part, this line also will never touch your -1. It will always keep moving towards your -1. Anyway, so if you draw the reflection as I mentioned, this is how the graph will look like. Things on the upper side will remain as it is. What was going lower like this, that got reflected to the upper part. Clear? Well, that's how your reflection of mod of f of x looks like. The next graph you're going to look at is how will minus f of x look if f of x is known. That's what we're going to look at. So if f of x is given, then minus f of x will be a complete reflection along x-axis. Previously, it was a partial reflection because only lower part will be reflected. Now, entirely lower part will go up and upper part will come down. Now, why is it happening? Because let us say f of x1 equal to 5, then minus f of x1, if I want to find my answer, will be -5. So whatever is positive here will turn out to be negative. Whatever is negative will turn out to be positive. So negative is becoming positive, positive is becoming negative, negative is becoming positive. Basically, it is reflection along your x-axis. So let's take a look at what happens and how does the graph look like. So if this is your f of x, which is given to you, then minus of this, basically everything on the upside will get reflected to the bottom, everything on the bottom will get reflected to the top. So it's a complete reflection, and this is how it will look with x-axis as your mirror. So f of minus x becomes a graph which is the reflection of your original f of x with respect to your x-axis. It is not a partial reflection, it's a complete reflection. Right? Well, the next thing we're going to talk about is f of minus x. Now, if the minus is within, what happens? So we have seen minus f of x, we have seen this, but now we are looking at f of minus x. Now, in this case, basically what it means is if you want to get the answer, if you want to get f of 2, if you have an answer, let's say is 5, and you have a function f of x where f of 2 is 5, you want to find out a function which is of the form f of minus x. Now you can see that in this, if you put f of minus 2, which means it becomes f of minus 2, if you want to find in this function, it becomes f of minus 2, correct? Because this is your x and you are already having a minus x. So minus into minus becomes 2. So f of 2, and you'll get the answer as 5. So basically the idea is this graph should be in such a way that whatever answer you get, you can get the same answer by putting the negative of this x, the negative of this particular x, which means the graph, as you can see, will be a reflection of y-axis. Will be a reflection of y-axis. Look at this. If f of x, I'll explain why is it a reflection about y-axis by looking at this. If your f of x is like this, then your f of minus x I want to find. Let's call it as g of x. G of x, it is actually f of minus x, correct? This is what I want. I want to draw the graph of this. So here you can notice that your f of 2, you can see that f of 2 is 1, or not even 1. It is, how much is this? This is your 1, this is 0.5. It's 0.5, correct? Now I want to draw the graph of g of x, but in g of x, remember, if I write g of 2, I will actually get f of minus 2. But if I write g of minus 2, what do I get? I get f of minus 2, which is my f of 2. And f of 2 I know is 0.5. So g of minus 2 will give me 0.5, which means instead of putting x as positive, this point I will get, the y I will get by putting x as negative 2. So this point is what it is. So if I same thing, if I want this point, I will have to go here in my g of x. So everything on the right hand side output you will get by putting it on the left hand side same magnitude, which means effectively you are transferring every point on the right side to the left side, and vice versa. Left side points you're transferring to the right side. So that basically is nothing but it is a reflection about your y-axis, and this is how your f of minus x will look like. As you can see, it's a reflection with respect to your y-axis. So this point reflection is like this, which is what we have, and the reflection will be like this, right? So that's your upper part reflection. Similarly, the lower part will also completely get reflected. So this is a complete reflection with respect to your y-axis. Please keep in mind. Okay, that is about f of minus x. The last couple of things is, now till now we have seen symmetry about a straight line, symmetry about an axis. Now you're going to see something called as symmetry or reflection, whichever way you call it, about a point. What is symmetry about a point? If you look at this first example, if I look at origin, the left half of the graph is a symmetry of the right half with respect to your origin. So you can see, if this point is here, then exactly opposite reflection I have here. If this point is here, exactly opposite reflection I have here. So what is the meaning of reflection with respect to symmetry? You take, so if I have this axis and if I have this point, I'm not having a line. And if I ask you what is the reflection of this particular A with respect to the origin, then draw a straight line joining A to the origin and continue drawing the line till the distances D and the distance D become equal, and this point now becomes your B. And B will be said to be the symmetry or symmetrical point or reflection of A now with respect to a point. It is not with respect to any line. It is with respect to a point. So you can notice here, this point, if I look at symmetrically, if I draw a line here, same distance, if I keep going, I'll get the symmetrical point. Okay, you have to draw it correctly. So, well, that's how you'll get. So this point and this point are symmetrical. So such a graph is called as symmetrical about a point. And this is another example. It's another graph which is symmetrical with respect to a point. Now, one thing you need to notice is it is not a reflection with respect to x-axis, because if it is reflecting, this should come here, and this point which is there should go here, but that's not happening here. Okay, so reflection about a point actually is very interesting. We'll see it in the next slide. Why is it interesting? So symmetry about origin, I already told you. We already showed an example, but we can see a new type of function. We have seen even function in the previous class, and we saw that it is the function itself I defined, and we saw the graph of an even function. It is symmetrical with respect to your x-axis, right? Symmetrical with respect to your x-axis. Sorry, with respect to your y-axis. Now we are talking about odd function. Odd function is f of minus x, which is equal to minus f of x. Such kind of a function is called as an odd function. Any function whose f of minus x becomes equal to minus f of x, then f of x is said to be the odd function. Then f of x is said to be odd function. Okay, for this function to be odd, f of x to be odd, this is the condition. So what is odd here? It is the f of x which is odd. Please keep in mind. So how does the graph of an odd function look? Take a look at it. Odd functions are symmetrical about origins. Odd functions are symmetrical about origin. Let's take an example of an odd function. If you take this f of x in the form of x cube minus x, then you can observe f of minus x is this much, and minus f of x will also be the same. Minus f of x will also be the same. So this f of x is said to be an odd function, and if you draw the graph for this, this is the graph. This is the graph for a odd function. It's always symmetrical about your origin. Now, if you want to find, so forget about odd functions, any function you take f of x. Now you want to find an answer to f of x which is symmetrical or reflected about a point called your origin. You want to reflect it or symmetrical, or you want to find it symmetrical about your origin. Now you're not saying whether f of x is even or odd, doesn't matter. Any function you're taking now. And this function, I want to find the reflection of it with respect to a point, or symmetricity of it with respect to a point. Now to do that, you can actually break it up into two steps. The first step is find the reflection of it with respect to y-axis. Once you get the reflection with respect to y-axis, then reflect it with respect to x-axis. So if I say that this function is like this, and I want to find reflection with respect to your origin. So you can see, you can imagine it will be somewhat like this. You can get the same answer by, finding first the reflection with respect to x-axis. So it will become like this, reflection with respect to x-axis, because this, when I reflect, it will become like this. Now reflect this with respect to y-axis. So you'll get the same answer. These two are same, right? So whether the order doesn't matter, y-axis first, then x-axis, or x-axis first, then y-axis, the order doesn't matter. But the point is, once about one axis, the others, the next about the other axis. That's what you need to do. Let's take an example. If you want to find, so if you are given a function f of x, and you want to find the reflection of f of x with respect to the x-axis, you need to find this answer. You need to find minus f of minus x, and this will be the reflection with respect to the origin, right? So let's look at example. So this is some function, let us say this is given to us. Now if I want to find the reflection of this with respect to my origin, it means this is my point of reflection. So this should go all the way here, this should come all the way, in fact not down, this should just come here, right? So let us see what will happen to my minus f of minus x. If I draw the graph for this, this is what it will become. So you can see that this part just becomes reflected about the origin, so it will be here itself, which is what we have here, and this lower part will actually get reflected and go completely to the top, which is over here. Now this can also be attained by doing the reflection with respect to two axes. So if you reflect this with respect to your y-axis, so then you will get it like this. So I'm trying to draw as much as I can. You get it like this, and this will become like this. This is reflection with respect to y-axis. After that, you're supposed to do a reflection with respect to x-axis, which means this will just be inverted and this will just be inverted up. And here you can imagine this is how you'll get. So this part A and part B, if I call, part A will be reflected with respect to your x-axis. So it will just, it will be flipping, and part B will be flipping up, which is exactly what you have. Right, so that's how you reflect functions about a single point. Well, with that, guys, we will come to the end of this amazing graph theory 5 episodes. I have covered almost all respects, everything which is required to various entrance exams like your DUJAT or IPMAT. I mean, there's nothing else which is required at this level for you guys with respect to graphs. Right? I hope you enjoyed the sessions. Thank you, friends. See you in the next session.